Okay, so we're in our last clip now. I want to look at the scenario where we train the baristas. So there are two human baristas. We pool them. So I'm lumping the two arrival streams together, sketching this for you. One arrival stream at the speed, the lumped speed, two servers, but they're trained. So the S is equal to 8 here in both cases. So that's implemented this way, and I can run that. So I can only run this one for 50,000 divided by 130 multiplied by 60, so 22,500 minutes. There it is. 1 second, 22.5. Can actually go a little bit more than that, but you'll see that I'm going to get up to, we'll see where it ends, but 49,000, 48,008. So this is a good enough estimate. So a little over a minute. I think the simulation, the queuing model gave me 63.4 seconds. So I was in that ballpark. The decimal accuracy isn't the greatest here, but you're getting confirmation that, roughly, from the perspective of, what this means on the average weight in practical terms is a little over a minute. And I think that, you can measure whether that's going to sort of fit the circumstances of the airport and the juice bar sitting there. Okay, so next up, we're going to consider two Juicebots. So they're now completely separate. You could pool them as well, I guess. And that would be something that I'm not going to test with you. But let's suppose that you had two Juicebots. So you're back in that original setting. And so arrivals are at the rate of 65 each. This is a Juicebot. S is equal to 0. It's a deterministic robotic device. And then it serves at the rate of 90 per hour. Its service time is 50 seconds as a mean. And, the other stream would have the identical setup. There'd be a robot here also. So essentially, what you can do is you can just analyze, let's try that again. You can analyze just one of these systems because they're identical. Just trying to clear this up here. So analyze if I had two Juicebots independent, this is 50 now, 0, and there's no humans, and there are two. In fact, I don't even need to change anything. All I need to do is just put the Juicebots in. It's actually one Juicebot, right? Because it's one of those two. Okay, so go ahead and run this. And when I did this, I think it came back at 232 seconds, which is a little over 4 minutes. So now I can go ahead and simulate for 45,000 seconds again, because there's 65 coming per hour. So 45, say 45,000. Go ahead and run this. And this one gave me a 5.04 minutes. Remember that the queuing model gave me over a little under 4 minutes, 232 seconds. You'd have to run this multiple times to get a good estimate. You can see that my utilization on the Juicebots is about 90%. That is confirmed by what I had in the queuing model, which I think was 90.3%. And then finally, the one model that we can't analyze using queuing, where I have one Juicebot and one human. Let's have a look at that one. So I'm going to just lay this out. Okay, so and I'm going to pool the arrivals as well. So let's see how this goes. Yeah, so it's going to be 130 per hour. Lump those two streams. There's a robot, let's say, and then there's a human. The robot does 50-second service. The human does 40-second service with, let's try a trained human. How's that? See how this goes. So this is the flexible option, right? This is where, you know, there's a robot on hand. The human can step in and take over or not, and it just frees up one of the two partners to do other things, perhaps. So to get this to go, we're going to have one of each. And the human, I have to put those human times in here, 40, and it's a trained human, so let's put in 8 here. And the arrival rate is, we're pooling. So I have one of each to serve those two, and then I think we can just go ahead and hit go. And see how this runs. So now 130, I'm going to simulate this for 22,500. And I'm just going to give it a go. So you can see the human is actually busy more than the Juicebot, 82 to 78. And the timing system is about 1.5 minutes, so about 90 seconds. So a little bit of a flexible option, human and robot, and this model, in fact, can analyze that. Hope you enjoyed this, and hopefully it was a soft landing for you with the queuing and the simulation.